All right. So that question said that you have a slope of -5, and that it goes through the point -2, -2. Okay, who remembers what is the slope? Rise over run. Good. So the thing to remember with lines, linear equations, is that if you have the slope, if you take a segment of the line and you figure out how much you go over the run, yeah.
Do we have to use a note card for this part?
Yeah, you get notes. You can actually have your whole notebook. So I would say take notes and write down example problems. You may use that to take the test.
Hold on a second, I need to get paper.
Yeah, I've got the yellow paper over there. So you don't necessarily have to write what I'm doing with this graph. I'm just trying to explain to you how to think about it. If you have a linear equation, the slope is constant on the line. It has the same slope no matter where you analyze it. If I take any segment between any 2 points on the line, let's say, the amount that I go over versus the amount that I go up is going to be a constant ratio. That ratio will always be the same on the line. That ratio we call rise over run. Even if I took a different interval, the rise over run will give me an equivalent fraction. Does that make sense? So imagine I have a point, like I have 2 points here. One of them is, I don't know, we'll say 0, 1. And the other is 3, 2. And then think of another point as a variable. You don't know what it is. You're just going to leave it as x, y. Well, if you have 2 points, if they give you 2 points and they want the equation of a line, all you have to do is say that the slope at one part of the line is the same as the slope at another part. It's even easier when they actually tell you what the slope is. So we know that the slope is going to equal slope. That's how you're going to set up for your equation of the line. The slope at one place is the same as the slope at another. Well, they tell us the slope is -5, so I'm going to put that on this side. And then on the other side, I'm going to put the rise over run. So I'm going to take my point that they give me, and I'm going to take another point, which is an unknown x and y, and I'm going to figure out the rise over run here. The way I do that is I take the difference between the y's. So I'm going to say y minus -2, and then the difference between the x's, x minus a -2. That's pretty much it. I mean, all you have to do is clean it up after that, but that's the equation of the line. So just the slope, -5, is equal to the rise over run. Leave one of your points as variable, x and y. The other point is the point that they give you. In this case, -2, -2. So all I got to do is simplify and rewrite. -5 is equal to, up here is y plus 2, because 2 negatives make a positive. And it's x plus 2. Is that okay so far? Okay. I guess maybe I should write this as rise over run. Now what they want is for us to get this equation. It's already the equation of a line. We already have it. They just want it in the y equals mx plus b form. So we just got to get y by itself. So all I'm going to do is rearrange this equation. I'm going to take the x plus 2 that's in the bottom, and if you think of multiplying it on both sides to move it over, you get rid of it on the right, because we're trying to get y isolated. And so we're going to have -5 is going to be times this x plus 2. and that's going to equal y plus 2. So all I basically did was I moved the denominator to the other side to multiply the negative 5. You're going to do that every time with these problems. Move the x part of the denominator over to the other side. Then all I have to do is distribute the negative 5. I'll rewrite that over here. So I have minus 5x. Minus 5 times 2 is minus 10. Then I have the right-hand side, y plus 2. And then I just got to subtract 2 from both sides to get y by itself. And so I see that y equals minus 5x minus 12. And now I have it in the form that they want. And we'll do more examples of that. But all I did was I took the slope, minus 5, put that on one side, and I said that has to equal the rise over run. The rise over run is y minus the y value of the point over x minus the x value of the point that they gave you. Then you're just rearranging, trying to get y by itself. So for that equation, I see that the slope is minus 5, as they told me, and the y-intercept is minus 12. Any questions on that one? Let's try, I might clear this.
What's this kind of problem called?
This is finding the equation of a line given the slope and a point. I'm going to give you another example. Let's say the slope is 3, and it goes through a point 2, 7. So I'm going to say that the slope is, and I'm going to imagine a point x comma y, an unknown point. I have to, in my equation, have variables x and y. So I'm going to say that the slope equals the rise over run, which is the difference between the y's. This y is 7, this y is unknown, y. So I'm going to say y minus 7. And then under that, I'm going to say x minus 2. That is already the equation of a line. I just need to write it in a different way where y is by itself. So again, I'm going to move the denominator to the other side. So it multiplies with the 3. Already pretty close. We'll distribute the 3. That gives me 3x minus 6 equals y minus 7. All that's left is to add 7 to both sides. So I get y, well, I'll just write it like this. 3x plus 1 is equal to y. That's pretty much my equation. The slope is 3. The y-intercept is 1. If I wanted to graph it, you start at the 1. And then your rise over run is 3 over 1. So over 1, up 3. Well, if I did that properly. So that is given a slope and given a point, find the equation of a line. we okay with that?
So that's also finding the equation on the line given the x.
Yeah, the
equation
slope.
point.
Yeah, the slope and a point.
Can I
Yeah.
go to the bathroom?
Yes, you may. So yeah, I would definitely have example problems so that when you get that kind of a question, you know what to do. All right, a slightly different one. Very similar, but in this case, they're not going to give you the slope. They're going to give you a second point. So I'll set up one like that. Are we okay to clear? All right. Let's say the point is,
Can I go to the bathroom when he gets back?
yes. We will say 1, 0.
Okay.
Well, I'll say 1 minus 1. And 3, oh no, 4, sorry. I'm going to go 3 to the right. 4, negative 7. So very similar. Only now I have 2 points instead of the slope. Again, I'm going to imagine a point x comma y. Now before, when they gave me the slope, I put the slope on the left-hand side. You could do it on the right, doesn't matter. It goes on one side. And then you do the difference in y's over the difference in x's on the other side. I'm going to do that same thing. For the slope, I'm going to take the difference in y's over the difference in x's for these two. So I'm going to say minus 7 minus negative 1. So I just took the difference in the y values, and I'm going to put that over 4 minus 1, the difference in the x values. Is that okay?
Yeah.
That's the slope, rise over run. On the other side, I'm going to use the x and y. I'm going to say y minus and x minus. And the numbers that go here, it doesn't matter. I can use either point. I can use the 1 minus 1, or I could use the 4 minus 7. It doesn't matter. I just have to use one of them. I like smaller numbers because I like to work with smaller numbers. So I'm going to go with this one because ones are easy. So I'm going to say y minus a negative 1 and x minus 1. I could have put the negative 7 and 4 in though. It doesn't matter. And that's it. That's the equation of the line. I just got to simplify again. The left makes minus 7 plus 1. That's a negative 6 over 3. That'll simplify to negative 2. On the right, I have y plus 1 and x minus 1. So when I simplify that left, I just have the same thing. So I can see that the slope is minus 2. Now I'm at the same point. This is kind of like where we started with the other problem. So now I'm just going to move the denominator over to the other side. So I'll have minus 2 times this x minus 1. And that'll equal y plus 1. And then what do I do next? Check out what you did on the last problems.
You have to do the parentheses.
What's that?
You have to do the parentheses like when
Yeah,
you
distribute.
them.
Yeah. So minus 2x. And then minus 2 times minus 1 makes a plus 2. Right-hand side's the same. Almost there. Just got to subtract 1 now from both sides. And I can see that y will equal minus 2x plus 1. That's finding the equation of a line given 2 points.
So basically you put together like 2 y's over the 2 x's.
Yep.
And then, so it's just basically like the y1, or y2 minus y1.
Yeah, that's exactly what it is. y2 minus y1 over x2 minus x1. Here you use a variable y minus either y, a variable x minus either x.
And then you just draw smaller numbers.
I like to work with smaller numbers, yeah. Okay. I'll do another example. Let me try we'll try 3 11 and 5, let me think, 19. How should I, and then of course imagine a point x comma y.
Oh, and that's up.
Let's back up.
Yeah.
How should I set this one up? I'm going to have the something over something.
So it would be 19 minus 11
Good.
over 5 minus 3.
Good. And then the other side.
It would be y minus the 11.
Mm-hmm.
If you want to go smaller.
Yep.
And then x minus 3. Or
Good.
x plus 3. Or
Minus.
minus.
Yeah. Good. Now that is already the equation of the line. It just needs to be simplified and isolate the y. 19 minus 11 is 8 over 2, right? What's half of 8?
4.
Yeah. So that simplifies to 4. That's the slope. And your y minus 11 over x minus 3. What's my next step?
You put, like, multiply it,
Yeah.
and then put it on the other side as well.
Yeah, we're gonna bring this. Hi, Ryan. We're reviewing for the last part of the test now. I'm going to bring the denominator over to the other side, so I have 4 times x minus 3 equals y minus 11. Now what do I do?
Distribute.
Distribute. We have 4 times x, and then 4 times negative 3. What is that?
It should be negative 12.
Negative 12. Y minus 11. What's my last step? Add 11. So now I have y by itself. And we have y is equal to 4x minus 1. Is that okay? All right, I think these will probably be the hardest ones on this next part. But especially if you take notes and have examples with you, hopefully it's not too bad. Any questions on these 2 types of problems?
What is this problem called?
Finding the equation of a line given 2 points. All right. I'm going to go through some of the other types of problems. A lot of them are a little more visual. Let's see if I can bring this over. Oh well. Check some of these out. All right, here's one of the examples that had a slope and a point, so we did some of those. And they just want to know m and b. So the number that multiplies x is the slope. You already know it's -4. The other one, once you figure out what that other number is in the equation, you'd have -4x plus something. That plus something or minus something goes here. You'll have some like this, where they just want to know what the units are. It's usually over time. Like if you have a rate of change, you know, it's rarely minutes per dollar. It's usually dollars per minute, or beats per minute, or miles per hour. The rates are usually over time. But in this case, in order for this to be money, they're talking about dollar amounts. This is a formula for the charge that they're going to charge you. So the charge is going to have to be in dollars. The base amount is going to be in dollars. The n, the variable, is number of minutes, so that's in time. So the units of the rate of change will have to convert minutes into dollars. So it's just usually over time. So that's going to be dollars per minute. Let's see. Here's one where you have 2 points. So you would do that like the last two that we just did. You'd take the rise over run for those two, and then you'd imagine a point x, y, and do rise over run. That's another one. Here they say find the equation of a line that has a slope of 7 and a y-intercept of -4. And they want it in slope-intercept form. So, anybody know what I should write? What's m represent?
Slope. Oh, 7x plus -4.
Yeah. So yeah, the seven is the m. The y-intercept is b, so that's -4. So it's just 7x minus 4. It's all right there in the question. So we did some of those. Let me find some others. Here is they give you 2 points and they want to know which one could be correct and which one isn't. They all have a slope of -7. Oops, I shouldn't be checking. So the slope they're all the same on the slope, so there's no difference here. The difference is what's added or subtracted to y and what's added or subtracted to x. Now remember, I can say y minus either of these y's and x minus either of these x's. It's just got to be the correct, the x and the y's have to go together. So if I said y minus -1, what would that make? Y minus -1 is actually +1, right?
Right.
So this is not correct. I would never have this. I could have a +1. But then the x would be minus -6. So which of these is the correct?
The one for the second to last. Right?
Not that one.
Oh, you have to add the 6?
Yes, yeah, because
Okay.
it's minus and -6.
So then it would be that one right here.
Yep. Now let's do the same for this point right here. Y minus 69 and y minus negative 16.
It'd be y minus 69 equals 7x minus 16. Or plus 16.
Yeah, plus 16, right?
Yeah.
So it'd have to be this one, yeah. Those should be the only two. Good. Yeah, it's always minus whatever these are. Where's this one? I don't think so. How about y equals 4? What does that look like?
It'd be up.
Yeah, I go up to y is 4. And basically, since there's no x in here, every x I put in, it just keeps outputting 4. So when I put in 1, 4. If I put in 2, 4. It's always...
So does it matter what part you're on the x-axis?
Yeah, that would be it. Just a flat 4 all the way across. Now this one's x. X is negative 3.
You go down.
Not down. On the x is the horizontal. So I'm going to go to this negative 3, and this will make a vertical line.
Okay.
So y is the horizontal, x is vertical. Let's see, they should have another one somewhere.
Are we, like, this part 2,
Yeah?
is that all just about lines?
Yeah, pretty much. So there you go. I think 14 and onward was on the first part of the test, so you don't have to worry about those ones on this part. Let's go back to the other questions. What's in this one? Okay, she rides for 11 hours and goes 33 miles. What's her rate? This is like rise over run, the slope.
33 over 11.
Yeah. Well, should have it here. Oh, they want miles per hour, so miles go on top. Do they want us to round or something?
No, so they want it like 3. The rate would be 3 miles per hour.
Oh.
Oh, yeah, they want us to simplify. That's okay. Okay, what's the rate here? Checks his pulse for 7 minutes, counts 812 beats. What are my units going to be? Minutes per beat or beats per minute?
Beats per minute.
Beats per minute. So this must go on.
116.
Is it 116?
Yeah.
Take your word there. Good. Yeah, you divide by 7. The falls that make up the Niagara Falls are eroding backwards, so the cliff is sort of receding as mud gets taken by water. It's gone back 20 feet in the past 10 years, so feet per year should be 2. Good. For this one, they want to know what the average rate of change is from 1999 to 2000. So you're going to do rise over run. You're going to take this number minus that number divided by this number minus that number. So how much did it go up?
370 minus 335. Divided by 2000?
The difference between 2000 and 1999. So that's just 1 divided by 1.
So that's 35.
Yeah, it's just going to be 35.
Oh.
35 over 1.
Because it's 1 year difference?
Yeah. Now this one will go from 1999 to 2003. What's 2003 minus 1999?
80.
What's that?
80?
No.
415.
No. Oh, I'm sorry. I was talking about the year.
Oh, okay. So 4 years?
Yeah, it should be 4 years, right? 1, 2, 3, 4.
Yeah.
And then did you say 80 for this
Yeah,
one?
with 80.
Okay, so 80 over 4. That's 40 over 2. That's 20.
Okay, hold on.
Is that okay?
Yep.
So that's how you do those ones. Does that make sense?
Yeah.
Now, this works the same way, but they're giving you a graph instead of a table. So just like before where we took the difference in the year, it was dividing the difference in the sales. Here we're going to take the difference in the y points. So they're saying from x equals 1 here, there's that point, to x equals 3, which is that point. So I'm going to have to zoom in probably. At x equals 1, I hate when they don't do it perfectly. I don't know. What do you guys want to call that? 6 3/4? 6.75 maybe?
Yeah.
So 6.75 minus 5. So that's 1.75.
Yep.
Divided by 3 minus 1 is 2. I don't know if that's what they want exactly. Let's try it. Nope. Don't worry about that though, because when they have these weird little things that you got to figure out, that's not going to be on the test. So it'll be a nice cut where it's supposed to be. All right. So these ones just want to know which function is linear. So the idea here is that it should change by the same amount every 5. So in 5 units, how much did I go up?
25.
Now, in the next 5 units, did I go up another 25? So that's not a line. Let's try this one. In 5 units, I went up how much?
20.
In the last 5, how much did I go up?
Not 20.
From 20. These last 2.
Yeah, 40.
From 76 to 96? The last.
I thought you about 36 to 76.
Be careful at that one because you don't actually move 5, you're moving 10. So that one should be double.
Oh, yeah, that's good then.
Yeah, that is a line. So this is a line, that wasn't.
But wait.
Be careful of that.
Oh, never mind. Okay, I understand.
Let's try this one. In 5 units, how much did I go up?
25.
In the next 5 units, how much did I go up?
25.
All right, and if that's another 25, that should be good. All right, so from 0 to 5, I went down 10 units. From 5 to 10, down another 10, down another 10. That's good. So we got those right. So you're just making sure that you're going the same amount in each interval. All right, what's the slope of this line? I like to find 2 spots that cross nicely. So how much did I go down?
10 or 8, 4.
From 10 to 4 I dropped, right?
Right.
So I dropped 6. But I moved over, be careful.
2.
Yeah, it's 2. So 6 over 2, it's got to be a negative.
-3.
Negative 3, right? Yep. Here's another one we want the slope of. Again, I don't like when they're not like crossing perfectly. So I'll try to find a spot where it crosses perfectly and then another spot where it crosses perfectly. So here it went from +2 down to -3. How much did it go down?
5.
Yeah, so it's -5 over, and how many units is that? 2?
Yeah.
Yeah. Just make sure, watch your signs. If you're reading the graph left to right and it's going down, it has a negative slope. And if it's, here's another negative slope. If it's rising, it's a positive slope.
So with those, do we have to get the fraction reduced, or can we leave it like?
You probably have to simplify.
Okay.
Find the slope. When they say the rate of change, it also means the slope, rise over run. Here they gave it to you not as a graph, but as points. What's the difference in y values? Good. So 6 minus negative 6 is 12. And then 3 minus 7 is
-4.
good. So that's going to be a negative. What's 12 divided by 4?
3.
Yeah, so it should be
-3.
-3. Good. One thing I'll point out is if you have a negative in the bottom, that's the same as this. And those are the same as this. So you can write it any way. But yeah, it should be -3. How about this one? What's the slope?
So it's -10 minus 9.
Minus -9.
-1.
-1 over 14, yeah. Good. All right. Is this slope here positive or negative?
Negative. Wait, positive.
Yeah, 2.5 is the slope. So it's not this line because that's a negative slope, and this is a negative slope. It's got to be one of these. Which one starts with a y-intercept of -3? This one or that one?
That one.
Yes, so it starts at -3. That's got to be the one. Good. All right. Is this a positive slope or a negative slope on this graph?
Positive.
So these first two are out. It's got to be one of these. Does it intersect at 3 or -3?
-3.
So it's got to be this one. Make sense?
Yep.
All right. B, that's flat. Which one do we think that is for the equation? Yeah, it's just y equals -3, right? So that's the blue one. No, that's C. Oh, that's tricking me. All right. Of the rest of them, K has a positive slope, the black line. R has an even steeper positive slope. K crosses at 1, 2, 3, 4. So which one has a positive slope that crosses at 4?
The last one?
Yeah? Yeah. So that would be K. Does that make
What
sense?
about the second one? Or
This-
is that not it because it's positive?
It's a negative slope. You see that?
Right.
So that's got to be the purple one.
Okay.
So this has to be the black one, which is D. That one's the downward slope at 4, so that's got to be the purple. Then there's 2 that cross at 0. There's no, see, the y-intercept must be 0. One of them has a negative slope. That's the green one, right?
So that's y equals -10.
Yeah. And the other one's got to be this one, the red. Good. This one, they just want you to graph a line. X-intercept is at -4, 0. And the y-intercept is at 0, -2. That's all you got to do. How about this one? Where should I start my line?
Positive half.
Now I'm going to start with the
Oh.
y-intercept.
And then go up and over
Yeah, so I'm going to go up 1
and over 2.
over 2, yeah. That's it. Make sense? Where do I start on this one?
2.
And then what do I do?
Up 3 over 2.
Nice. What about an x equals 2?
Just go up 2.
Not up.
Over 2.
Yeah. So go on the x-axis, and it's every point whose x-coordinate is 2. So just something like that. Remember, x is the input and f of x is the output. f of x equals 1 is the same as y equals 1. That's the same as y equals 1. So what should I do here?
So you should do 1 and then just to the right one.
Yeah, this is just like y equals 1. So if you see that, just think of it as y equals 1. Y equals negative 4?
Down 4 and then 0.
Yeah. Y equals 4. It's pretty much the same. X equals 5?
So you should go right 5 up 1.
Right, 5, yeah. There you go. Where do I start on this one? And then what do I...
Round 1 over 30.
Good. Nice. All right. RX, the solid line, represents how much money you make as you sell bikes. That's your revenues. C of X shows you the cost of producing that many bikes. And that's the dotted line. The question is, how many bikes must the company sell to break even? 8, right? I have to input 8, and then the output is the same. Good. I don't think I'm going to do it with that one. So the initial distance from Lois, Superman swooping to save Lois. So you put in a time of 0. So his initial distance will be 15. Initial number of hot dogs in this graph?
2.
Yep. Yeah, that's the y-intercept. In 2003, the population was 36,000. It's grown by 2,700 every year. So write an equation for where x is the number of years after 2003. So what should my y-intercept be? My initial value.
3600.
Yeah. And then my slope. Yeah. And then times the number of years. That should be it. Does that make sense? That's the rate at which you change as x grows. And this is your starting value.
Hold on a second, I want to write this one down.
Okay.
No, would that mark it wrong? Like, it shouldn't mark it wrong, but would it?
Nope.
Okay.
Is that okay? All right, this next question is very similar. This toy company introduced a new toy. It cost them $10,000 to develop the toy, and then cost them $10 to manufacture each toy after that. So how much they spent to produce so many toys would be, n is our variable this time instead of x, but we need an initial cost and then the rate times n. So what should I put as my initial cost? 10,000. And then what's my rate?
$10.
Yeah, times n. That should be what they want. And then when n is 3,000, I would just plug that in. So 3,000 times 10 makes 30,000. Plus that should make 40,000. And then with 34,000, how many could I make? For that one, I would set that equal to the 10,000 plus 10n. So I got to figure out what n would make that true. So I'm just going to solve this equation. You can subtract 10,000 from both sides. That would make this like so. And I divide by 10. So the answer should be 2,400. Oops, I forgot to answer that one. Is that okay?
Yeah. I think I need to write this one out too.
Okay.
Here, I'm just gonna take a picture of it so I can do this.
Okay. All right, so those, I think those are a little bit easier than the first couple that we looked at. Last ones. So let's see. Yeah, if we look at this one, we see points where this line crosses the x-axis. Here's where it crosses the y-axis. Here's where this line crosses the y-axis, and here's where it crosses the x-axis. And here's where the two lines cross each other. When we're talking about like this, when you have a system of two equations, when you find the solution, which of these intersections represents the solution to the equation, to the system? It's C, yeah. So that's all you'd have to say is C is the solution. In this case, they want to know what is the solution as a point.
3.
The y would be 3. What's the x? 4. So I should put in 4 comma 3. Does that make sense?
Yeah.
So they'd want it like that.
Is this test also going to be on like the My One now?
Yeah. So you have questions like that. This one, you don't really have to solve this. You just got to look at the graph. What's the coordinate of this point?
3, negative 3.
Good. 3, negative 3. Good. Graph A, well, you don't have to worry about that part, I guess. We already did solving systems on the first part of the test, so we're not going to do that on this part. I think that's pretty much it. Yeah. Yeah. So it's a lot of like linear relationships. Do you understand slope? Do you understand how to graph things, given them in slope-intercept form? Things like that. I think the hardest thing will be finding the equation given 2 points or given a point in the slope. But yeah, have your examples with you, and then that shouldn't be too bad. Any questions for me?
No.
All right, you guys got a few minutes to study or work on something else?